Hello all. Let us. I'm going to explain about an experiment in control system lab, how to plot Bode plots, and the main aim of this experiment is to obtain the phase margin and gain margin for the given transfer function by plotting using Bode plots. Okay. So the transfer function given is 2000 divided by s cube plus 10s square plus 200 s. You all very well know that this is not in the standard form. It has to be brought to the standard form. When you bring this down to the standard form, it will be 2000 divided by s plus 2 into s plus 100. Now this will be a standard form. Standard form here means it should be in the form 1 plus 0.5s into 1 plus 0.01s. Okay. Now this is the given transfer function in the standard form. You need to first theoretically calculate what will be the gain margin and phase margin, and you all know how to do that. First step will be you should find out what is 20 log k. 20 log k will be your 20 decibel actually. This will be 20 decibel, and then you need to tabulate for different roots. So first you are going to consider the pole at the origin, then a simple pole, then another simple pole, and you are going to calculate what is the contribution for the magnitude from each pole to the magnitude plot with respect to their corner frequencies, and you are also calculating what will be the phase contribution with respect to different frequencies. So all these calculations are done practically. This has to be verified theoretically. This can be verified theoretically by writing a code in MATLAB. I'll show you how to write the code in the MATLAB. So this is the code in the MATLAB. It starts with clear all. Then you have your NUM, which indicates the numerator coefficients, D in denominator, and then you are going to find the transfer function. TF stands for transfer function. This is the transfer function of the numerator and denominator, and one good thing in MATLAB is that if I simply directly give Bode, it will plot whatever is the transfer function given. It will only calculate what is the gain margin and phase margin. It's only a 4-step program. So once you type all these steps or statements in your MATLAB, save the program, and after saving the program you have a green button here. It's visible. It's a green button here. When you keep your cursor on the green button, it says run. Just press on that. You can see that there is this command window that is prompted. It is asking you to enter the value of numerator. Enter the value of numerator. As per our transfer function, the numerator we had taken it to be 2000. So type 2000. Okay. Then give enter. Now it is asking for denominator. In denominator you have 3 different values. If you have more than one value, you are supposed to open a square bracket and then enter 3 coefficients or 4 coefficients depending on your system with a space in between. So the first coefficient is 1, then give a space 10, and then give a space 200. Close the bracket. Now give enter. See now, when you give enter, you can see that directly you are getting your magnitude plot and phase plot. What you are supposed to check is you are going to verify this with respect to your theoretical calculations and see what is the gain margin and phase margin you have obtained. At which point you want, if you click the cursor, you can see it will give us how much is the magnitude and how much is the frequency at that particular point. So here it says your phase margin is 13.4 degree. Look here, 13.4 degree at 46.3 radians per second. So this will be your gain margin. This should be equal, or I can say approximately equal to your theoretical calculation. You need to compare your theoretical calculation and your practical value, whatever you have obtained. So this is your Bode plots.